Hello students, welcome to my channel Ravi Physics Vidya and my offline coaching center Vidya Education, Surat, Gujarat for IIT JEE, NEET and Foundation, Path for the Best. So presently I am discussing 11th physics series, okay, and chapter name is Work, Energy and Power. And already I have discussed in the previous clip about the work done, right? Various types of the work done, like that W is equal to F dot delta S, F dot S final minus S initial. Delta S, this is the displacement here, finite displacement, okay. And already I have told you, whenever you are calculating the work done, then you just take the idea about it is path dependent or independent, okay. So tell me please, this is work done. And this work done is this formula F dot delta S, in which case we are using it if vector F is equal to constant, okay, and this is path independent because you are observing it, this is the S final and this is the S initial. We are not discussing the intermediate part, just we are taking S final, S initial, alright. In the same manner, one more formula W, work done, is equal to F cos theta into actual path. It is quite obvious. Actual path means path dependent. For example, work done by kinetic frictional force Fk. It is the path dependent. Already I have discussed a problem connected with it. Now my mind is acting over another case. First case, second case. Now I am discussing third case. Work done. In that part, force is oriented towards a particular point. What? Force is always oriented, right? Force is always oriented towards a particular point. See, suppose this is a point here and a spring is connected with, and this is the block here, and movement of the block is like that, okay. This is the fixed, we are observing that movement of the block is in this direction along the circular arc, nice, but kx is acting in this direction. So what is our case here? Force is always directed towards a particular point, right? So in that case, how we can calculate work done? This is the important thing. Okay. If I take it is x axis, is y axis, and there is a point xy, this is origin, this is called vector r. If I take origin, then this is called vector r. Yeah, you can say if any force is in outward direction, then it is r cap. And if it is towards the origin, it is minus r cap, okay. And vector r is equal to what in general? It is xi cap, yj cap, zk cap. Whenever the value of the force is in form of xi cap, yj cap, zk cap, then you always use work done is equal to F dot dr, right? If the value of the force is given in terms of, sometimes it is given that vector F is equal to xi cap, yj cap, zk cap, right? So xi cap, yj cap, zk cap, it is nothing, it is the vector r. And what about vector dr? Differential change in the vector r, okay. Differential change means vector r में differential change भी हो सकता है. Very good. dx I cap, dy j cap, and dz k cap. Okay, more generalized, w is equal to f r cap dot dr if it is outward from the origin, if it is acting in this direction. Otherwise, if it is acting in towards the particular point, always directed towards a particular point, then w is equal to f, okay, f minus r cap dot dr. And always keep in the mind, r cap is nothing vector r by mod of r. Okay, and what about vector r dot vector dr? Angle between them is 0 degree. Cos 0 1, it is nothing, it is r dr. So this is the these things, these are important things actually. R cap is equal to, tell me please, vector r upon mod of r, and r dot dr, it is nothing, r dr. These are very smaller things but very important. In actually any theory, any problem creates by the smaller things, and it makes a bigger problem. If you are knowing the fundamental things, basic things, it means you are going to be ready crack any problem. Whenever we are studying, we should focus about the cracking ability of the any problem, and it comes by analytical study of the smaller things, smaller terms and terms. Okay, so now I take a problem here, right? Question. All right. See, this is the earth here. Okay, I take a center here, mass m, and suppose this is a body having mass m, a small m, and it is coming like that. Final radius r, initial radius is 3r. Body is passing through these points like that. The path is given here, you are observing it, and you know that gravitational force acts, always passes towards the center, always passes from the O. It's working like that. It is working like that, isn't it? We are observing that body is moving like that, but force is always directed towards a particular point. Already I have discussed, I am discussing the calculation of the work done, in which force is always oriented towards a fixed point. Force is always directed towards a fixed point, right? And it is not a big deal. Actually, already I have said W is equal to F dot dr actually. Yeah, F vector r cap dot dr or F minus r cap dot dr. There are the three formulas, fundamental formula. We can use it according to situation. R cap when force is directed towards outside from the origin, and minus r cap it is towards the origin actually. So see the case, this is the case here. It is directed towards this point. One important thing, you don't use mg here. Mg is taken, means a constant force, when we take a smaller height, but here the height is the level of the 3r is a very big height, so force is variable here, right? We cannot take mg. Okay, now see, tell me please, which formula is used here? I suppose it is F minus r cap dot dr because it is oriented towards. Okay, so W is equal to integration over F minus r cap dot dr, all right, is equal to G capital M by r square minus sign here r vector r by mod of r and dot dr, all right, minus gmm by r square, gmm out of integration 1 by r square. RDR is nothing, already I have discussed, it is the RDR actually, RDR and by r, this is the cancel here, all right. And what is the limit of the r? We are discussing intermediate distance r here. See, initial height is what here? 3r. Okay, and final height is what here? R. Now, see, 1 by r square dr. Integration is minus 1 by r. Minus 1 by r. Minus minus plus. So now it is equal to, work done is equal to GMM by r here. And limit is what here? 3r to r. So GMM and 1 by r minus 1 by 3r. Alright. I suppose you are understanding properly. Okay. So GMM and LCM is what here? 3r. 3 minus 1. 2 GMM by 3r. Joule. Answer. So we are understanding this. Okay. Next question. Suppose I take a force vector F is equal to 2i cap, 3j cap and 4k cap, right? And suppose it is displacing 0, 0, 2, 2, 3, 1. Just see the category. What is this? Constant force, right? F is equal to 2i cap, 3j cap. This is the constant force. Therefore, work done. F dot delta S is equal to F dot S final, S initial, right? 2i cap, 3j cap, 4k cap dot S final 2, 3, 1 minus 0, 0, 0, right? 2i cap, 3j cap, 4k cap, 4k cap dot 2i cap plus 3j cap plus 1k cap. 2i cap, 3j cap, 1k cap minus 0i cap. Now this one 4 plus 9 plus 4, 17 joule. Answer. Clear? This is the work done by the constant force. W is equal to F dot delta S. S final positions. And this is path independent. This is the path independent. Okay. Question. F is equal to xi cap, yj cap, zk cap. This force is acting on any body and body is displacing by 0, 0, 2, 1, 2, 3. Okay. Already I have told you, whenever force is in terms of x, y, z, it is nothing. It is the vector r. Then use W is equal to F dot dr, because you know that r is equal to xi cap, yj cap, zk cap. Whenever the force is in terms of the x, y, z, means it is variable force, and dr is equal to dx I cap, dy j cap, dz k cap. So whenever you are using F dot delta S or F dot ds or F dot dr, everything has certain meaning, certain logic, right? This is the important point of this topic. Now if xi cap, yj cap, zk cap, right? And what is dr? dx I cap, dy j cap, dz k cap. And what about the limit here? 0, 0, 1, 2, 3. Okay. Now x dx plus y dy, z dz, 0, 0, 1, 2, 3. So dear friends, actually purpose of this program is get confidence. Whenever you are dealing any subject, physics, chemistry, math or bio, you should have ability to crack the problems with confidence, right? Now it is x dx, y dy, z dz, x square by 2, limit 0 to 1 plus y square by 2, 0 to 2, and z dz, z square by 2, 0 to 3. Okay. Now it is 1 by 2 plus 4 by 2 plus 9 by 2. 14 by 2, 7 joule. Answer. Clear now? W is equal to F dot dr. Right. Answer is 7 joule. One thing more. Other method. W is equal to F dot dr here. Right. And F is what here? F is what here? X I cap, Y j cap, Z k cap. It is nothing, it is vector R. Okay. And display 0, 0, 1, 2, 3 means mod of R is equal to under root 1 square, 2 square, 3 square, root 14. Clear now? Under root 14. Now it is R dot dr, because already I have said you, whenever you are observing that force is in terms of X I cap, Y cap, Z cap, this is means this is radial force. You always use vector dr is equal to F dot dr. Okay. Now R dot dr, tell me please. R dr already. R square by 2, limit 0 to under root 14, means 14 by 2, 7 joule. Answer. Right. Okay, thank you.